Hello everyone, and this is part 7 of my lecture series for differential equations. And in this video, we're going to talk about the first order ordinary differential equation that is linear. So here, we're going to identify whether a given differential equation is linear or not and how to find its general solution. But let's first define what's a linear differential equation. And you know that a linear differential equation is an equation of the form dy dx plus p of xy equals q of x, where p of x and q of x are functions in terms of x. And this is a linear differential equation with respect to the dependent variable. In this case, it's y. Okay, and this differential equation will lead us to an integrating factor of the form e raised to the integral of p of x dx. So here, we're going to solve for the general solution by simply multiplying equation 1 and 2, and that is dy dx plus p of xy equals q of x times the integrating factor, and you just simply multiply this integrating factor each term inside the bracket, and you shall have e raised to the integral of p of x dx times dy dx plus p of x times e raised to the integral of p of x dx times y equals, you copy q of x and then you affix the integrating factor e raised to the integral of p of x dx. And then to simplify, you just simply multiply this by dx. Okay, so we shall now have e raised to the integral of p of x dx. Then you just you will just only have dy here plus p of x e raised to the integral of p of x dx y, and then you simply affix dx. Okay, equals copy q of x e raised to the integral of p of x dx, and then simply affix dx. And then here, you can now let u be equal to the integral of p of x dx. And you know that the derivative of the integral of p of x dx is simply p of x dx. You know that the derivative of the integral of a function is the function itself. Okay, so you can now replace integral of p of x dx by u and p of x dx by du. So you shall have e raised to u, and then you just simply affix dy plus e, then integral of p of x dx is our u, and then you just simply affix y, copy y, and then this p of x dx is represented by du equals, you just simply copy q of x, then e raised to the integral of p of x dx, and then copy dx. And then, okay, so you can just recall that the derivative of e to the uy, okay, by applying the derivative of product is equal to e to the u dy plus y e to the u du. So you can just replace this by derivative of e to the uy, and then you just copy the right side. So we shall have the derivative of e to the uy, that's your e to the y, e to the u dy plus e to the uy du, okay, equals q of x times the integrating factor e raised to the integral of p of x dx times dx. And this is our equation 4. So what are we going to do now is you just integrate equation 4, and that led us to the integral of the derivative of e to the uy equals the integral of p of x e raised to the integral of p of x dx times dx. And then you know that the integral of the derivative of e to the uy is simply e to the uy equals the integral of q of x e raised to the integral of p of x dx, then you just simply add c. So this is the general solution that we are looking for. And then you just, again, you write it back to the original variable. So this is u, and u is represented by integral of p of x dx, all right? So therefore, the general solution of a linear differential equation is written of the form e raised to the integral of p of x dx, that's our integrating factor, multiplied to y, equals the integral of q of x times e raised to the integral of p of x dx, then times dx, and then you add c. Now, you recall that this this linear differential equation dy dx plus p of xy equals q of x. Okay, so this is a linear differential equation in terms of x, but if we will solve it in terms of y, so the equation dx dy plus p of y times x equals q of y is also a linear differential equation with respect to the dependent variable, and this time it's already in x. So where p of y and q of y, these are function in terms of y. Okay, let's have some example. Say we wish to find the general solution of the differential equation, the quantity 1 plus x squared times dy minus dx equals to xy dx. So what we're going to do first is to rewrite this of the form either dy dx plus p of xy equals q of x, or the other one dx dy plus p of y times x equals q of y, whichever is applicable between these two linear differential form. Okay, so what I'm going to do now is I will divide everything by this is dx, we don't want dx here, and we don't want 1 plus x squared here, so we just multiply this by 1 all over 1 plus x squared dx. And then you can now have, when this is multiplied each term inside, then you will now have 1 plus x squared times dy minus dx all over 1 plus x squared times dx, then equals 2xy dx all over 1 plus x squared dx. And you can now cancel this out, all right? And then you can cancel this out. Eventually, you will only have dy dx or dy minus dx all over dx is equal to 2xy all over 1 plus x squared. And then what we're going to do is you just simply distribute this dx each term on the numerator. So you shall have dy dx minus 1 equals, and then you just isolate this y, okay? You regroup 2x over 1 plus x squared, and that leads you to the quantity 2x all over 1 plus x squared times y. And you recall the general form of a linear differential equation, dy dx plus p of xy equals q of x. So we will rewrite this of this form, and that will give us dy dx, okay, plus minus 2x all over 1 plus x squared times y equals 1. Okay, and you can now see that p of x is represented by negative 2x all over 1 plus x squared, and q of x is represented by 1. And this gives us an integrating factor of the form e raised to the integral of p of x dx, and that's e raised to the integral of p of x dx, that's negative 2x all over 1 plus x squared. And then to integrate negative 2x all over 1 plus x squared dx, we just simply let u be equal to 1 plus x squared, all right? And this leads you to an ln function. So this is 2x dx. So you should just simply have negative, you affix it in front, and then 2x dx is simply du all over u, that's 1 plus x squared, all over u, and that's negative ln of u. So that's negative ln of 1 plus x squared. And that's the integral of negative 2x over 1 plus x squared dx. And then our integrating factor can now be written as e raised to the negative ln of 1 plus x squared. And then to simplify, you can just write this of the form by loss of exponent or by loss of logarithmic function. So that's ln of 1 plus x squared raised to negative 1. You recall that r ln x is equal to ln x raised to r. Okay, and you know that e raised to ln x is simply equal to x. So we can now write this as ln of e raised to ln of 1 plus x squared raised to negative 1 is just simply equal to 1 plus x squared raised to negative 1, or by loss of exponent, that's 1 all over 1 plus x squared. So based on the process that I have presented earlier, so this integrating factor will be multiplied to our linear differential equation. Okay, so this is 1 over 1 plus x squared. So we shall have, okay, that's the general form. So you will have 1 all over 1 plus x squared times y equals, you just simply replace q of x by 1 and then copy the integrating factor and then you just simply affix the x equals the integral of 1 times 1 all over 1 plus x squared dx plus c. Okay? And then to integrate this part, you can now write this of the form integral of 1 times 1. So just simply 1 and then dx all over 1 plus x squared. And this gives us an arctangent of x. And then you'll have 1 or just y, 1 times y, that's y all over 1 plus x squared is equal to arctangent of x and then plus c. And then you can just multiply this by 1 plus x squared. Okay. And then that leads us to y equals the quantity 1 plus x squared times arctangent of x plus c. And this is the general solution of this differential equation. Okay. Another one. Say we wish to find the general solution of the differential equation of the form y plus 1 dx plus 4x minus y dy equals 0. Again, so to identify whether this is linear in x or linear in y, we just simply write it of the form dy dx plus p of xy equals q of x, or dx dy plus p of y x equals q of y. Okay. So if we want to have this dy dx, so what I'm going to do, so I'll just copy this first, y plus 1 dx plus 4x minus y dy equals 0. And if you want to achieve this form, dy dx plus p of xy equals q of x, you just simply avoid dx here, okay? dx, and we don't want this 4x minus y to get along with dy dx. So that's 4x minus y and then 4x minus y. Observe that this will now become y plus 1 all over 4x minus y. All right, then this will become 1 plus this will be canceled out, dy dx equals 0. And you can just rewrite this of the form. I will just write dy dx first, okay, plus then you just distribute this 4x minus y each term on the numerator, so you'll have y all over 4x minus y, okay, plus 1 all over 4x minus y equals 0. And you can notice that if this is dy dx, so you'll have dy dx plus 1 all over 4x minus y, then times y equals negative 1 over 4x minus y. Now, if we let p of x, I'll just write it here. If we let p of x equals 1 over 1 all over 4x minus y, because this is y, and you can just see that the x and the y are mixed up, okay? So this is not linear in y, okay? This is not linear in y, so what we're going to do is to identify whether this is linear in x, okay? So how do you do that? So you must write this of the form dx dy plus, that's dx dy plus this must be p of y x equals q of x, okay? So what are we going to do? So if we want dx over dy or dx dy, so we just don't want dy here, okay? So we divide everything by dy, all right? And we don't want y plus 1 here. So we just divide this y plus 1, okay? Or we just multiply this by 1 all over the quantity y plus 1 dy. And then when this 1 all over y plus 1 dy is distributed each term inside the bracket, okay? So then this will be canceled out. So you'll have y plus 1 dx all over y plus 1 dy, okay? Plus 4x minus y all over, dy all over y plus 1 dy equals 0. So this can be canceled out. So you now have dx dy, all right, plus, then this will become, hold on, this is dy, and then this will be canceled out. So you only have 4x minus y all over y plus 1 equals 0. And then you can now distribute y plus 1 each term on the numerator. So you have dx dy, all right, plus 4x all over y plus 1 minus y all over y plus 1 equals 0. And then we can now write this of the form dx dy plus, so 4 all over y plus 1. Okay, we regroup that term, and then you just simply affix x equals, and then you throw this on the other side. So y all over y plus 1. So we are now of the form dx dy plus p of y times x equals q of y. All right. So this means that our, okay, p of y is 4 all over y plus 1, and our q of y is y all over y plus 1. Okay. So this is a linear differential equation in terms of the dependent variable x. Okay. And then this gives us an integrating factor of the form e raised to the integral of 4 all over y plus 1 dy. And you know that the integral of 4 dy all over y plus 1 is simply 4 ln of y plus 1. So we shall have e raised to 4 ln y plus 1. And again, by logarithmic identity, so this is equal to e raised to ln y plus 1 to the 4th power. And that can simply be written as y plus 1 to the 4th power. And this is our integrating factor. Okay? And then we use the general equation of, or general solution of this linear differential equation of the form e raised to the integral of p of y dy times x equals the integral of q of y e raised to the integral of p of y dy times dy, and then plus c. Okay, so we shall have e raised to the integral of p of y dy. This is, by the way, this is our integrating factor. All right, so that can be written as y plus 1 to the 4. Okay, so this is 1 or y plus 1 to the 4, our if or integrating factor, and then you simply affix x equals the integral of, and then q of y, that's written of the form y all over y plus 1. Okay, and then again, this is our integrating factor, y plus 1 to the 4. All right, and then you just simply affix dy, and then you add c. All right, so you shall have, and then you just multiply this 2. Okay, so you'll have y plus 1 integral of y times y plus 1 to the 4 all over y plus 1 dy, or you just write this of the form y times y plus 1 cube dy. Okay, and then you can have the integral of y times y plus 1 to the 3rd power dy. So you just simply let u, by change of variable, be equal to y plus 1. And you know that du is dy. And since we have y here, all right, then you can just get y in terms of u. So that's y equals u minus 1. So we shall have y, that's u minus 1. Then y plus 1 to the 3rd power is u cubed. And then you just simply affix du. All right. And then you can just introduce u cubed each term inside. So you shall have the integral of u to the 4 minus u cubed du. So that's u. Okay. And then you'll have u to the 5 over 5 minus u to the 4 over 4. And then I simply do not add c here because this is our integrating factor. Okay. And you can just write it of the form y plus 1 to the 5th power. You just replace u by y plus 1, okay, all over 5 minus the quantity y plus 1 to the fourth power of all over 4. And again, I simply do not write plus c here. Okay, and then this shall be used to replace this one. All right, so we shall now have y plus 1 to the fourth power times x, okay, equals the integral of y all over y plus 1 times y plus 1 to the fourth power dy is just simply equal to this. Y plus 1 to the fifth power all over 5 minus y plus 1 to the fourth power all over 4 plus c. Okay, and then you can just multiply this by y plus 1 raised to negative 4. And then the LCD of 5 and 4, that's 20, sorry. That's 20, all right? And then you shall have 20x on the left term, on the left side. So that's 20x equals y plus 1 to the fifth power times y plus 1 to the negative 4 is simply y plus 1, all right? And then 20 divided by 5, that's simply 4, minus, you know that this y plus 1 to the fourth power times y plus 1 to the negative 4 is simply equal to 1. Then 20 divided by 4 is simply 5. And then plus c times 20, okay, y plus 1 to the negative 4. All right? And then you shall have this. And you know that this c times 20, this is another constant c. So we shall have 20x is equal to 4 times y plus 1 minus 5 plus c times y plus 1 raised to negative 4. And then you can just simplify this by introducing for each term inside. So you shall have 20x, 4 times y, then 4 times 1, and then minus 5, and then you just simply copy c, y plus 1 to the negative 4. And you know that this 4 minus 5 is simply negative 1. And finally, we shall have 20x equals 4y minus 1 plus c times the quantity y plus 1 raised to negative 4. And this is the general solution of this differential equation. Okay, one more. So you have y prime equals cosecant x plus y cotangent of x. So you can write this of the form dy dx, that's our y prime, then equals cosecant of x plus y cotangent of x. And you can write this of the form dy dx, and then this y cotangent of x, you throw it on the other side, to the left side. That's why you have here negative cotangent of x times y, and then you just keep cosecant x on the right side. So you shall have dy dx minus cotangent of x times y equals cosecant of x. And then you can now see that p of x equals negative cotangent of x, and q of x is cosecant of x. Okay, and then the integrating factor is e raised to the integral of negative cotangent of x dx. And you know that the integral of cotangent of x dx is simply ln of sine x. So therefore, e raised to the integral of negative cotangent of x dx is e raised to negative ln of sine x. Okay, and then again, by laws of logarithmic function, so you shall have ln of sine x raised to negative 1, or this is sine x raised to negative 1, or this is 1 over sine x, or by reciprocal identity, that's cosecant of x. That is our integrating factor. And then you use this general solution. Okay, and then our integrating factor to be replaced by cosecant of x, and then you just simply affix y. I will write it in front, equals the integral of cosecant q of x. Q of x is cosecant of x, and our integrating factor, that's cosecant of x. All right, and then you just simply affix dx, and then you add c. Okay, and then you can now see that this cosecant x times cosecant x is cosecant squared x. All right, and you know that the integral of cosecant squared x is negative cotangent of x. Okay, and you can simply express this in terms of sine and cosine. So that can be written as y. You know that cosecant of x is 1 over sine x equals negative. Cotangent of x is cosine of x over sine x, and then you just simply add c. And then you just multiply this by sine x, and then you just have y equals negative cosine of x plus c sine x. All right? Yeah. And then multiply it by sine x. So you'll have y equals negative cosine of x plus c sine x. And that's the general solution of the given differential equation. Let's have some more. I think there's another problem here. Yeah. That's y minus cosine squared x dx plus cosine x dy equals 0. Okay. Again, you just write this of the form dy dx plus p of xy equals q of x to identify whether this is linear in y, or the other one, dx dy. Hold on, that's dx dy plus p of y times x equals q of y. Okay, let's try the first one. Say we don't want dx here, all right? So we shall divide this by dx. And we don't want cosine x here. All right, so you shall have y minus cosine squared x dx plus cosine x dy equals 0, then multiplied by 1 all over cosine x dx. So you shall have y minus cosine squared x all over cosine x, then this will be cancelled out, right? Then plus, this will be cancelled out, so you only have dy over dx equal to 0. Okay? And then you just introduce this cosine x, each term on the numerator by distributive property of division over addition. So you have y over cosine of x minus, you know, this cosine squared x all over cosine x. All right? And this is simply equal to cosine of x. Then you just simply add dy dx equals 0. So we shall have y all over cosine x minus cosine x plus dy dx equals 0. And then you can now write this of the form dy dx, all right, plus 1 over cosine of x times y equals this negative cosine of x. You just write it on the right side of the equation. So this is cosine of x. So this is a linear differential equation, and that's linear with respect to the dependent variable y. So here, you can now see, or this 1 over cosine x can be written as secant of x. Okay? So you can now see that our p of x is secant x and q of x is cosine of x. And this gives us an integrating factor of the form e raised to the integral of secant of x dx. And you know that the integral of secant of x dx is ln of secant x plus tangent x. And again, I will not write plus c. So you shall have e raised to ln of secant x plus tangent x. And then that is equal to secant x plus tangent of x. And then we use this general solution. Okay, our integrating factor multiplied by 1, integrating factor multiplied by y equals, okay, the integral of q of x, that's cosine of x, all right, times our integrating factor, so that's secant of x plus tangent of x, and then you just simply affix dx, and then you add c, okay? And then you can now distribute this cosine x, each term inside the parenthesis. And you know that cosine of x times secant of x is equal to 1 because these two are reciprocal of one another. And then cosine of x multiplied to tangent of x, where this tangent is sine x over cosine of x. So you can just cancel it out, and that is just simply equal to sine x. So we shall now have secant x tangent x times y equals the integral of 1 plus sine x dx plus c. And you know that the integral of 1 is equal to x, integral of 1 dx, plus, you know that the integral of sine x dx is negative cosine of x. So we shall have secant x plus tangent x times y equals x minus cotangent of x plus c. And yeah, this is the general solution of this differential equation. You can simply write this in terms of sine and cosines. Okay, so again, if you want to write this in terms of sine and cosine, that secant x, you write it as 1 over cosine of x plus tangent of x, that's sine of x, over cosine of x. And then you just simply affix y equals x minus cosine of x plus c. And then you just multiply everything by cosine of x. So you shall have 1 over cosine of x times cosine of x is simply 1, plus sine x over cosine of x times cosine of x is simply sine x, and then you simply affix y equals x cosine of x minus cosine of x times cosine of x cosine squared x plus c times cosine of x. And this is also a general equation equal to this secant x plus tangent x times y equals x minus cosine of x plus c. Last problem. Say we have 2y dx is equal to x squared minus 1 times dx minus dy. All right. So to write this into the general form of a linear differential equation, I have to multiply. I have to multiply everything by. Okay. So we don't want dx here. So 1 over dx, and we just simply don't want x squared minus 1 here. So times x squared minus 1. So we have, okay. I just simply multiply it by 1 over dx. And then later on, we will multiply it by 1 over x squared minus 1. So you shall have 2y equals x squared minus 1, then times dx minus dy all over dx. And this gives us 2y equals x squared minus 1 times dx over dx, that's simply 1, minus dy dx. All right. And then this x squared minus 1, you just divide everything by x squared minus 1. So you have 2y all over x squared minus 1 equals 1 minus dy dx. All right. And then you can now simply write this of the form. This negative dy dx, you throw it on the left side, so that's dy dx, and then we regroup this as 2 all over x squared minus 1 times y, and then you keep 1 on the right side equals 1. Okay, so clearly you can see that p of x is equal to 2 all over x squared minus 1, and q of x is equal to 1. Okay. And this gives us an integrating factor of the form e raised to the integral of 2 all over x squared minus 1 dx. And then to integrate 2 all over x squared minus 1 dx, you just simply recall the integral of du over u squared minus a squared is equal to 1 over 2a ln of u minus a all over u plus a plus c. And where u is x, a is equal to 1, and you know that du is dx. So we shall have 1 all over 2 times a, that's 2 times 1. Then ln of u, that's x minus a, that's 1, all over u, that's x, plus a, that's 1. Okay, so you shall have this. That's 1 over, hold on, I forgot this 2. Okay, I will write it here. So that's 2 over 2 times 1, and that is just simply equal to 1. And then we only have ln x minus 1 all over x plus 1. So you just have ln x minus 1 all over x plus 1. Now, if you cannot recall this formula, you can integrate 2 all over x squared minus 1 by partial fraction. So we shall integrate that 2 dx all over x squared minus 1. So we shall decompose this into partial fraction of the form 2 all over x plus 1, x minus 1 equals, you know that the denominator contains linear factor of the form x plus 1, non-repeated, plus b all over the second linear factor, that's x minus 1, also non-repeated. And then you multiply everything by x plus 1, x minus 1. So you shall have 2 equals a times x minus 1 plus b times x plus 1. And then by Heaviside cover-up method, you can let x equals to 1. So you have 2 equals a times 1 minus 1 plus b times 1 plus 1. So this is equal to 2 and this is 0. So you have 2 equals b times 2 and therefore b is equal to 1. And if x equals negative 1, so you have 2 equals a times negative 1 minus 1 plus b times negative 1 plus 1. And again, this will become 0. This is negative 2. So you have 2 equals a times negative 2. Therefore, a is negative 1. And this can now be written as the integral of a, okay, where a is negative 1 over x plus 1 plus b, where b is 1 over x plus 1, then dx. And you know that this negative, the integral of negative 1 dx all over x plus 1 is negative ln x plus 1. Then the integral of 1 dx all over x plus 1 is ln of x plus 1. Oops, it's x minus 1. Sorry. This is x minus 1. This is b all over x minus 1. So that's 1 all over x minus 1. So therefore, you have ln of x minus 1. And then I will not simply write c plus c. And then by laws of logarithmic function or by logarithmic identity, ln preceded by minus sign, you write it on the denominator. Preceded by plus sign, you write it on the numerator. So you shall have ln of x minus 1 all over x plus 1. And this is our integrating factor. E raised to ln of x minus 1 all over x plus 1. And that can simply be written as x minus 1 all over x plus 1. Okay? And then we will be using this general solution. The integrating factor times y. All right, that's x minus 1 all over x plus 1 times y equals integral of q of x. That's 1. And then the integrating factor, x minus 1 over x plus 1, and then simply affix dx, and then you add c. Okay? And then to integrate this part, you can just simply divide x minus 1 by x plus 1. So you have x minus 1 divided by x plus 1. So x divided by x is 1. 1 times x is x. 1 times positive 1 is plus 1. And then you subtract. So this will become 0. Negative 1 minus 1 is negative 2. So therefore, that is equal to the integral of 1, the quotient, then minus 2 all over x plus 1, then dx. All right? Okay? And then you know that the integral of 1 dx is simply x. And you know that the integral of this part is L2 ln of x plus 1. So minus 2 ln of x plus 1. Okay? You shall have x minus 1 all over x plus 1 times y equals x minus 2 ln of x plus 1 plus c. And then you just simply multiply everything by x plus 1. And then you shall have x minus 1 times y equals x plus 1 times the quantity x minus 2 ln of x plus 1 plus c. And that is our general solution for this differential equation.